Section 4.7 is on congruence transformations. A transformation is an operation that maps an original figure, which we call the pre-image, onto a new figure called the image. A transformation can change the position, the size, or the shape of a figure. But in this section here, we're only going to be focusing on congruence transformations, sometimes called isometries. It changes the position of the pre-image, but not its size or its shape. In other words, the image, the pre-image, and the image are going to be congruent to each other. We're just going to be changing its position. There are three types of congruence transformations. The first one is called a reflection or a flip. This takes the pre-image and flips it or reflects it over a line of reflection. Each point on the image is the same distance from the line of reflection as its corresponding point on the pre-image. So for example, the distance from C, point C, to the line of reflection is the same as the distance from point F to the line of reflection. The distance from A to the line of reflection is the same distance as D to the line of reflection. We say that triangle ABC is mapped to triangle DEF. ABC is the pre-image, DEF is the image, and it's just been flipped over that line of reflection. Another type of transformation is called a translation or a slide. This moves all the points of the pre-image in the same distance and in the same direction. In other words, triangle ABC here is just slid kind of down and to the right to the new position of triangle DEF. Triangle ABC is mapped onto triangle DEF by a translation. And the third type is a rotation or a turn. This moves the pre-image around a fixed point, which is called the center of rotation, which is this purple dot right here, through a specific angle and in a certain direction. So triangle ABC was rotated 90 degrees clockwise, 90 degrees clockwise to end up with the image of DEF. Let's take a look at a couple examples from your textbook. And here it says, identify the type of congruence transformation shown as a reflection, a translation, or a rotation. So going from the blue shape to the green shape, and in fact they kind of give you a little hint here because they're showing that the origin is probably the center of rotation. The blue shape is rotated in order to end up on top of the green shape. So that would be an example of a rotation. In B here, the blue shape is flipped over the y-axis to give you the green shape, so this would be an example of a reflection. And in this case, the y-axis is the line of reflection. And here, in example C, the blue shape is slid up and to the left in order to get the green shape. That would be considered a translation. So let's take a look at a couple here. So in example 1A, we have, let's say we're going from the blue triangle to the green triangle. That would be a reflection, because you could actually take the blue triangle, flip it over the x-axis, and get the green triangle. And let's see, so for the trapezoid here, the blue trapezoid to the green trapezoid, it looks like it's just been rotated probably about 90 degrees clockwise. So that would be considered a rotation. And from the blue pentagon to the green pentagon, doesn't look like it's been rotated or flipped, it just looks like it's been slid to the right a couple units, so that would be a translation. It's been translated a few units to the right. Oops. Translation. Here's a real-world example. Actually, this is an interesting little toy. This was one of my favorite toys when I was younger, where you put it around your ankle and then you swing it around and kind of jump over it every time. So this diagram here shows the movement of the little ball on the end of the loop around your ankle from this position to that position. So this would be an example of a rotation, because as you swing your leg around, the little ball on the end rotates around the center of rotation, which is your ankle. Okay, identify each of these congruence transformations. Here we have the door on a minivan. Obviously it is sliding over, so that would be a translation. And 2b here, we have two footprints in the sand, and I could imagine that something like that could be a line of reflection. And I know your feet aren't exactly the same, but that would be considered a reflection. And our last example here asks us to graph each pair of triangles, identify what kind of transformation it is, and then verify that it is a congruence transformation. So let's go ahead and graph these. So I have A is -4, 5, B is 0, 2, and C is -4, 2. So that's A, B, and C. And X is -5, -4. Y is -2, 0. And Z is -2, -4. So let's see, this one was X, this is Y, and this is Z. Okay, and looking at these two triangles, it's not a reflection because it actually is not quite in the same orientation. It's not a slide, it's not in the same orientation, so this is actually going to be a rotation. And at this point we don't really have to worry about what the center of rotation is or how many degrees it rotated, but obviously triangle ABC was kind of spun around so that it would end up where XYZ is. Now, to confirm that it is a congruence transformation, I have to show that AC is the same length as, that would be XZ. I have to show that BC is the same length as YZ, and that AB is the same length as XY. And maybe since this is, most of these are pretty straightforward, AC is 3. AC corresponds to XZ, which is also 3. So both of those segments are 3. BC is 4. And XY is, or I'm sorry, YZ is also 4. Okay. And now this is a little more difficult. I can't just count the number of squares for AB and XY. Okay. But I could, I know we haven't officially learned this yet, but I could use the Pythagorean Theorem because actually both of them are 3 and 4. So I can say 3 squared plus 4 squared is equal to, I'll go with AB squared, or 9 plus 16 is equal to AB squared. So AB squared is 25. I'll give myself a little more room here. Or AB is equal to 5. Now, is XY going to be the same thing? In fact, it is, because XZ is 3 and YZ is 4, so those are both going to be 5 units long. So, when it says verify that it is a congruence transformation, you're going to basically be using side, 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 and show that all of the corresponding sides are indeed congruent to each other. In this case it was easy because I had a 3 and a 4 where I could just count the boxes, and then since it appeared to be a right triangle I could use the Pythagorean Theorem to figure out the third side. But to verify that it's a congruence transformation, you have to show that all of the corresponding sides are congruent by using SSS.